All right, quotient rule and tangent derivative. All right, so here's the rule for the quotient rule. All right, it says if f of x equals g of x over h of x, then f prime of x equals h of x times the derivative of g of x, so g prime of x, minus g of x times h prime of x divided by h of x squared. Okay, so that is your quotient rule. All right. Now, I gave you a rhyme for the last one. Here's a little rhyme I found for the first one. I didn't make these up if you're wondering. It's low D high minus high D low square the bottom and away you go. Alright, so low D high minus high D low, square the bottom and away you go. That is the rhyme if you want to use it to help you remember this. Alright, so let's look at an example. Say we had f of x equals 1 over x. Alright, f of x equals 1 over x. Well, we know if we did this just regular derivative way, without using the product rule, this would be x to the negative 1, because we bring the x to the top. We'd drop this down and subtract 1, so this would become negative 1 over x squared. All right, let's see if we get the same thing using the quotient rule. All right, so f prime of x, remember, it's low d high, so this is your high, so it's your top function, and this is low, meaning your bottom function. So it's low d high, so x derivative, and then the derivative of 1 is just 0, minus high, which is 1, and then the derivative of the bottom, which is 1, divided by the bottom squared. So over x squared. So this cancels out. 1 times 1 is 1, so it gives us negative 1 over x squared. And as you can see, they both gave us the same answer. All right. So let's look at another example. Say f of x equals x plus 2 over x minus 3. All right. Let's find f prime of x for this one. So remember, it's low d high, so x minus 3 times the derivative of the top, which is 1, minus high d low. The derivative of the bottom is also 1, over the bottom squared, x minus 3 squared. All right, so this is going to equal, this is simply x minus 3 minus x minus 2 over x minus 3 squared. So the x's cancel out here, leaving us with negative 5 in the top and x minus 3 squared in the bottom. All right. So that is f prime of x of our function here, f of x, x plus 2 over x minus 3. Negative 5 over x minus 3 squared is our derivative. All right. I'm going to have you try one now. So pause the video for a few seconds after I write the function down, and see if you can find f prime of x. Alright, so pause the video and find f prime of x. Alright, so we start out with low, so sine x, d high, so the derivative of the top, which is 2x, minus high, x squared plus 1, d low, derivative of sine is cosine, over the bottom squared. So this would be sine squared x. Alright, now you can either leave it like that, or there's many different forms you can write it in. You can also say 2x over sine x minus x squared plus 1 times cosine x over sine squared x. Or you could also say 2x cosecant x minus x squared plus 1 cotangent x cosecant x. Alright, so there's several different ways to write this, and I would take any of the three of them if you gave me to me. Alright, so that is your quotient rule. Remember, low times d high minus high times d low over low squared. Alright, so the bottom derivative of the top minus the top derivative of the bottom over the bottom squared is your quotient rule. Now let's look at the derivative of tangent. Alright, we know that the tangent of x equals sine x over cosine x, and that's actually what we're going to use to solve this problem. So, derivative of tangent, oops, that's a t, of tangent x dx equals low d high minus high d low over low squared. So this simplifies down to cosine squared plus sine squared divided by cosine squared. And if you remember from pre-cal, which you should, the numerator here, cosine squared plus sine squared equals 1. So this is 1 over cosine squared x, which is simply secant squared x. So the derivative of tangent is secant squared x. You'll need to remember this. Derivative of secant of tangent is secant squared x. Alright. So let's try another problem using the derivative of tangent. So let's find f prime of x if f of x equals sine x tangent x. Alright, so for this we're going to use product rule, and this is our first function. This is our second function. So remember, it's 1 times d2 plus 2 times d1. Alright, so 1 is going to be sine x. Derivative of the second one is going to be secant squared plus 2, which is tangent x, times d1, which is cosine x. Alright. Now you could technically leave it in that form, or you could convert it down. There's a couple different forms you can write it in. Since this is 1 over cosine squared x, this would actually turn into tangent x secant x plus sine x. I'd take that too. Or you could factor out a sine x, and you could also get secant squared x plus 1. Alright, I would take any of those forms. Alright, so this has been your quotient rule and tangent derivative video. Make sure you know how to take the quotient rule. Make sure you've written it down. Make sure you remember that rhyme. And also be sure to remember what the derivative of tangent x is. Remember, it is secant squared x. Alright, see you tomorrow in class.